it. One is Excel. You can see it Excel. One is data. Not all of you have data, right? Otherwise, I would have used data. But since Excel is common, right? All of you have Excel sheet or online data access tools also there. Plus, there is a library in R software which I use. So since Excel is common, may have it Excel. So we opt this. Have you touched this? Yes, no? Could you get it?
Yes.
Now it's getting downloaded, right? It's getting, so I'm downloading. I'm also opening it. Yeah. Now what I'll do, I'll stop share and agree with this. So you can see the data set, right? Yes, no? You can see? Let me save it. Now you have the data, right? Do you see the data? The sheets in the data. You have to give the reference. This is the reference because these are the people who worked on it, developed it. They prefer you to acknowledge. As per IPR, intellectual property regime, we are accountable to it. We should be very ethical, right? Because we got this data, we should acknowledge. Now this is the legend, you can see, right? Definitions. So there is first layer, identifier variable. So it has country code, then country name, currency, year. So these are the identifiers. Then GDP, employment and population. So expenditure side, GDP is measured from different angles. One is expenditure, one is output. Then population here, number of persons engaged. Real means it is sanitized against inflation. Inflation is removed. There's no inflation in it. If there is inflation featuring here, it's called nominal GDP. So inflation is removed, or current it's called. Employment, EMP means number of people engaged in millions. Average hours of human capital. Current price means inflation is not taken care. It's inclusive of inflation. But we want to be secure, right? We want our data to be insulated against inflation. So let's avoid this current part. Then there is national accounts based variables like real GDP, real consumption, domestic absorption, capital. Capital means value of plant and machinery. Capital service at constant prices. Service means mostly software and other intangibles. The total factor productivity. It means, see, when you look at a particular economy, growth is either due to resources deployed or due to factors other than resources. So, for example, learning, innovation. So, total factor productivity captures that part. Then labor share. Labor share means the money, monetary value of money that goes into wage out of GDP. Internal rate of, that's not very crucial for us. Similarly, exchange rate, I will not look into that part. So there's so much data you can see, right? Now coming to the data. Can you see it? Data. Can you see this?
Yes.
You can see it, right? This has many countries, nearly 180 countries. You can see it. Just touch out there. This many countries are there. This many countries. So you can filter out India if you want, but we will do it later. But let's keep data as it is. You can see it, right? Data. So all the variables are here. Yeah. So what really comes here? You take one country, Aruba. Aruba is a country. You have data from 1950 to 2019. That many years. For India, for example, you may have this much data. Look at India. This much data you will get. So for all, not for all countries you will get this long data. For many countries you have this data. So that cleaning is very crucial. Anyway. So you want to restrict to India, then select all. Most of us know it, this part. How we use it in Excel. Yeah. You get India, right? You get India. So for this many years, from 1950 to 2019 years, you get the data. Now we have some core questions about it. In India, relation between GDP and output and employment. That's a very interesting question. Will employment grow according to GDP? Right. So that's an interesting hypothesis, right? What do you think? What do you teach people? Do you think will employment grow according to GDP? More the GDP, will you get employment? That's a crucial question, right? This is an important question, right? As economy expands, are we going to generate more jobs? If economy expands by 1 unit, what would be the volume of increase in jobs? So these are all very, very foundational. Some of these hypotheses emerge, and we can really look into it. So how would we do it? So first, I think instead of prior to moving, prior to applying some visualization, Tableau, let's stay over here in Excel itself. How would you examine the hypothesis? And I would like to have your responses. You can come up with responses. We have a question here. There's a fundamental question here. What is the question? Let me put that question up front to you. This is the question. This is the question. Does job expand? Does jobs increase? Does job or do does job or does job or do jobs is also fine. Do jobs expand? When the economy expands or when economy grows? That's a question. So that's a research question. Now, to answer it, see, this is a big question. There are many issues. You have to ask people. People may have experiences, but here there's a data set. Pertinent to data set, how can we approach this question? Do we have data on? Do we have data on jobs? That's the first question. If yes, for how many years? For how long? Do we have data on economic growth? If yes, for how long? Now let's look at the legend. Do we have from this? Let's look at this. Do we have data on people, jobs? Do we have data on jobs here? Do we have data on jobs? So this is the data on jobs, right? Number of persons engaged. And do we have data on uh, economic growth? One of the data which we can depend on is real GDP. So we can look at GDP as a factor. So we have GDP. We have number of persons and GDP. Right. So let's see. Let's put this data. We have employment. This is for India. We choose this. This is employment. And then we can choose the other data, which is with us. That is RGDPNA. You can see here. It is GDP. Let's choose this data. So we choose this. We have two, right? You can see it here, right? And then we have another data over the years. This is about India. Let's see all the years. Here the years. So we have three pieces of information here. Year, employment, RGDPNA, that is GDP. It's crucial, first of all, it's crucial for us to understand what's going to be the behavior over the years for employment and output separately. So first, let's do this. We have chosen these two data, year and employment. And we insert a figure here. This is what we get, right? So this is about employment. So over the years, employment has been growing. But now let's see the behavior of GDP. So let's plot the second data, insert. Now it's to you. Please help me. I think your non-participation makes my situation very vulnerable. Is there a story emerging from this? What is this? This is employment. This is employment. Let me write it, employment. This is the GDP, real GDP. Now, my question is, there are two systems here over the years. One is employment, another is GDP. Can we say they behave same way? What story emerges from here? Yeah. Now I think you can see it, right?
Yes.
Yeah. There were font. Okay. I'll expand a little more. Now you can see. What do we observe here? Do we see same behavior? Yeah. What are the observations? What do we observe from this data?
There is no steady growth in employment, but if you look into real GDP, it is going up steadily.
There is a steady growth for GDP, right? The real GDP. That's right.
Suhasti has also written something.
Yeah, but do we see same behavior originating or shown by these two things? What are the core differences? Of course, I agree with you. In employment, there's no steady growth, but GDP, there is a steady growth. But what do we infer from it? What do we conclude from it? Or is there a difference across history when it comes to employment or concerning GDP? Do we see a crucial difference?
So employment, I'll try to explain. We can see that although GDP is growing, but employment is not growing as per the growth of GDP.
Yeah, particularly after 2000, right?
Yes.
This is more evidently post 2000
yes.
or 2010.
2010.
There is a sharp increase in GDP, you can see. Why we say sharp? See the delta here.
Yes.
2010 to 2020, for one decade, this much change has happened. One might argue it's because of inflation, but we have removed inflation. We should keep that in mind.
Yes. Because
what is the what is the scenario in job? What is the scenario?
Stagnant there, no? So
it's almost almost stagnant, right? So now let's do this. So this is all the years what's happening to employment, and over the years, what's happening to GDP. Now, let's, without bringing the year explicitly, implicitly it's there, let's create third plot. That's between employment and GDP. So let's do this. Insert. We'll do a, yeah. You can see it, right?
Yes, yes. I request the host to unmute Amitabh Avinash because he want to respond.
Yeah. So you can see it here, right? So here, let me just a second. Let me edit this graph. Then it's more clear. Sorry.
Amitabh Avinash can unmute himself.
This is GDP. This is employment. Employment in millions. Huh? Employment. What do we observe here? I hope you can see it, right? The third map.
Yes, sir.
Yeah. What do we observe here? What is the story emerging? Therefore,
We can see only one map of GDP. The previous one is not seen.
yeah. No, the GDP employment relation. Yeah. You can see it here, right?
Yes, yes.
Let me edit it once
yes,
again.
Yes.
Let me edit it.
Yeah.
Format axis. I'll just put it from 100.
Now I got it. You have put GDP on y-axis and employment
on
x-axis.
Yeah. Now you got it, right?
Yes.
Yeah.
So this map shows that as GDP is increasing, and there is an increase in employment too. Isn't it?
It is, but
there is a direct relationship, but again, it's a shaky. You can see it's not.
So
it's not linear.
You
it is non-linear kind of a relation.
You can see. You hear what happens.
Yes.
For a big change, you
big
see.
Change.
I think just a second. Let me just draw. I'll draw a line. Just a second. Yeah. You see the slope here. What is the meaning of this slope? This is delta GDP.
Delta GDP, yes.
This is delta employment.
Yes.
What is the meaning here?
Meaning is GDP is growing faster than the employment. When you can see, if you measure the change,
that means economy expands hugely.
But
employment increases a bit.
A bit, gradually, yeah, very less.
That's the meaning, right?
Yes.
Yeah. So that's what we get, right? So now there is an issue here. You ask a question. For 1% of change in employment, 1% of change in GDP, supposing GDP increases by 1 unit, what would be the increase in employment? How can we answer that? Now let me remove all the figures. You got my question, right? For one unit increase or a proportionate change, let's say GDP grows by 1 unit, that is a proportionate change. Employment rises by 1% or X percentage. How will we find out? Is there a trick? You can do it by converting that to logarithm. So we find out ln employment, logarithm of employment, log employment, log GDP. Log GDP. How to find it? Can we do it in Excel? Any idea? Can we do it in Excel?
Yes, sir.
Can we do it in Excel? How will we do it in Excel? Okay, fine. Let me share the screen. So let's do it. Log function, yes. So let's apply the log function. So what to do for that? There's a log function equals natural log we take. There are 10 base logs or natural base log. We take natural log and then D2. Then we can paste it. This is what we get, right? 2 decimals we keep. And this is logarithm of employment. Same way we can find out logarithm of GDP. ln again you can get it, right? You can see it, right? Yeah. So log employment and log GDP. Let's plot it now. You're going to plot it. Insert. Can you see it? Now, this format is not good for us. So we change the format, go to quick layout, and okay, this is not good for us. I think we'll take this. Axis title. What is axis title here? It is log I think yeah. Oh, employment comes first. Okay. Yeah. Let's plot it. Just a second. Yeah, this is employment. Yes, fine. Oh, sorry. Yeah. So here, employment. Log GDP. And now we have to prune this. We can format axis. Minimum, let's make it 3. Or even 4 is fine. Here, we can make it 10. Okay. You can see it, right? So the advantage of log model is it prunes extremes and it gives you a reasonably good story. Otherwise, you show what was shown was sharp turns, which is tough to interpret. But then the moment you have log, it's closer to interpreting what would be the proportionate change. So in order to do that, we can run a regression. But then the problem here is there's a problem with Excel sheet. What is portrayed on x-axis, horizontal axis, is taken as an independent variable. And what is on the vertical axis, here GDP is taken or is understood as independent variable. It should be the other way. So GDP should come here, employment should go out there. We can change the axis. There itself we could have changed the axis, but I'm just taking a shortcut here. Let's do it here. And you have to change values. It is D2. Yeah, you have all the values. Again, let's plot it. There's some problem. Yeah, it's coming. It's getting filled. Yeah. Yeah, now let's fit it. So let's insert it. Now we get right. Now we click on the right axis here, add trend line, and then we get a linear curve, then display R square, display equation. You can see an equation here, right? Equation we can write log employment and this is log GDP. So what it says is if GDP expands by 100, expansion in employment is going to be 39 during over the period 1950 to 2019. So that's what Excel tells us. But Excel has a lot of limitations, by the way. And that's where visualization packages like Tableau comes to your aid. More creatively, you can handle this issue. So I delete it now. How we handle Excel sheet more effectively. That's very crucial here. So I change all the alterations we made. So for example, we filtered the data, filter has been removed and data remain as it is. We don't even save it. Now we you have to download something called Tableau Public. I'm sure most of you may not have Tableau Public, but you can download it. So I'll show you it in Google first. Have any of you used? Have some of you used Tableau before? Do you teach Tableau to your student, which is very crucial for contemporary times to get job and analytics? So Tableau, it's called Tableau. Tableau public. You can download Tableau public. You can see it, right? It's free of cost. So I opened Tableau now. I showed you what is Tableau, how to get the Tableau. Now, let me open it, Tableau. It's getting open. Then I'll share the screen. Tableau is open now. So, have you heard of Tableau or have you worked with Tableau before? Yes, Ahmed. Ahmed, you would like to say something? Now I'll share the screen. Can you see it, right? Yeah. Now it is shared, right? Now you can see it's the first question is connection. It accepts different types of files. Microsoft Excel, text file, JSON, PDF, spatial file, GIS type, statistical files. I hope you got this, right? Now, I'm clicking here because ours is an Excel sheet, right? And we have this file, PWT100. That's what we just downloaded. I just open it. Now, can you see it? Now you have three sheets coming over here, right? Data, info, legend. Which one should we choose? Is it legend, info, or data? That's my first question. What is legend? Legend is definition. Information is citation. Data is the information what we need. What should we choose? So we have to choose data. Data here. Can you see it? We have all the data here. So we have the data here. We have got the data. We have absorbed the data here. Now we go to worksheet. So we have see the structure. There is source data. We have sourced the data. All the data, right, which we saw in Excel. So 52 fields, one at 12,810 rows. So that much data we have. So we have data source and sheet. Go to sheet 1. I hope you can see it, right? Yes. Now we want to see the question we raised, right? The same question we can see. So you can see two layers of data here. One is here. Second is measures. This is called dimensions. These are dimensional data. This is country. Country is a dimensional data because it's categories with a geographical meaning. That's why you see a globe here, right? You can see a globe here. Globe means it's a spatial data. and a currency unit. Touch here, you can see here, right hand side, there's a map coming. That means it's a special data. There is a currency, then there is a data, currency unit, which is a categorical data. That's why it's ABC is given. So then ICIG, IIRR, these are not categorical. I think it's erroneously given. This is an error. So that we can change the data if you want. Say for example, but we don't deal with them. So leave it. We are not going to analyze them. So we can afford to let them here, let them be here, but we are not going to touch it because it's not our variable. The information we look for is different. So it doesn't matter, although it's not really ABC. ABC means categorical. So this is geographical data. ABC means something like gender. This category, the other category. These are all ratio scale variables. Ratio means there's a continuous measurement. This is average hours of work, or here it's labor share, variety of data you get. You can see it. So we are interested in employment. Let's see, let's pick that data. So that's called measure. So let's put employment. Let's see employment. Where is employment? Here's the employment. There's employment here, but nothing comes here, right? Because rows we haven't yet filled. So our fundamental question is, what is the relation between employment and GDP? So we use another variable, RGDPNA. Still we haven't got anything, right? There's nothing coming here. The reason is we haven't yet filled here. There's something called detailing. We have to detail them out. We have to detail. We have to provide the detail. So for example, EMP. Just a second. Yeah. Now let's take, before coming to it, let's take employment. And then we can see, I think that's one, before coming to the relation, I thought it would be good to segregate by geographies. So we can do that actually by bringing country here. That's one opportunity. You can see it here, right? So, but look at this. Do you think it's a right data? Is this a way of doing? Is there something wrong with this data? What we have done? You see this. It says that you look at India. Here, what it says is this many million. It's in millions, right? 21,800. How many? What is the workforce in India? What is the labor market size in India? Employment. How many people are employed in India? Any idea? How many people are employed in India? How many jobs are in India? How many people have jobs in India? Any idea? It's nearly, it's more than 500 million. That's the latest approximately 500 million data, 500 million units, persons, head count. But what we have the number here, look at this. Let's see this number. Can you see this number? Here it's saying India, if you see, 21,806. Should we believe this? What must be the mistake here? What must have gone wrong? There's something gone wrong? In fact, this is a panel data. Panel means we have multiple years and multiple countries. And the map can't work for multiple years, right? It can, but you have to have separate map. And map is a cross-sectional data. Otherwise, you have to have very interactive automated maps. What do you call it? For every years, map changes its color. It keeps on moving, like a rotating map. This is not a rotating map. It's not an interactive map. It is very, very stagnant. So that means you have to control for years, right? You haven't controlled years. So you can control here. Go to filter. You can put it as a filter. You can. So this is a filter, the show filter. And edit filter. This has the data from 1950 to 2019. But we want it only for 2019. Okay. Now you see, is there a change? There's a change, right? Now, employment in India, 2019 is 500 million. In China, 800 million. Likewise, you can see the change. So the advantage of this way of capturing is interesting. You can convert this into a dashboard. So I'm creating a dashboard. Drag sheet 1 here. This is called dashboard. And it looks like this. So you make a product out of it. That's advantage. You can see it, right? You can edit it. Or you can screen print or you can save it in your Tableau account. So you can choose according to your liking. You can filter it out. So that's a story of analytics, a simple story of analytics. I think we can explore more, but two things we did today. One is to get a public data, Penworld data, explore the data set. It's a panel data. Panel data means multiple years, multiple countries. Then we extracted, what do you call it? We could even extract data for India. Then the second step, what we did, we uploaded Excel sheet in Tableau. We could have done more, but then owing to the paucity of time, I just showed you how to read it and then visualize it and convert that into a product, or how to make a dashboard. Dashboard is a product, information product, data product. We could explore more, but I hope this is what we mean by visualization is. Of course, you can arrive at a lot of data, or arrive at statistics and interpretation. I'll show you that, but then I just want to have an interface before moving to the next stage, next phase. So I solicit your views. Would you like to share your reflections? What have we learned from this, or is it a passive participation, or have we got something out of it? Let me know. This is a possibility, because whatever resources we used, these are all free of cost. We could use it and share with students. And also it would be useful for research, because you can easily create a map, you can alter it, many things you could do. Any reflections, any views before moving to the next step? But I think only 10 minutes left now.
Any questions from the participants? You can either unmute and ask or put it in the chat box. We'll take it up quickly. Rashmi Pillai madam has written new concept heard for the first time.
Okay.
Personally, for me also, I've heard this for the first time and like totally floored by how much is available and that we don't know about it.
I guess it's important to try with that. Try in the sense, it's important to engage with it. Then we learn. One shot is not enough to do it.
Yes.
But our advantage is this is the happening thing now. If we use it in teaching, I'm sure students will gain immensely. Also, you can really revolutionize your research product.
Absolutely, absolutely.
So I just showed you, right, how to project it in a map. The
Right.
same way you can do it for India, if you have state-wise data, because the moment Tableau reads it as geographical data, it will plot accordingly. Imagine you have multiple years data for states, then you get an evolutionary feature, right? How things evolve. Of course, there is more to do. Plus, you can make an information product out of it.
Right.
And many people get patents, etc. for this.
Oh.
Even in social science, you can earn patent. It's called data curation. So people, not only scientists get it, you can also. This could be done in another package, which is called RShiny. But RShiny, the disadvantage is you have to know a little bit of programming skills, or you have to have programming skills or developer skills. But
Okay.
Tableau doesn't require that. Tableau is easy to operate, and plus you have Tableau public. And also there is Tableau business version, which could be purchased by universities, etc. But for an individual Tableau public could be. But then the output I showed you, the map, can't be saved like Control S and etc. That's not the way. Either you can take a screenshot, you can and clip it according to your needs, or you can save it. For example, you can save it virtually. Virtually means you get an account. If you provided you have a Google account, Gmail account or something, then you can also post it as a what do you call it, almost like a website. And you can keep on updating this data as you need. That's how it becomes a product.
Right.
So all these are possible. I just showed you very, very limited version of it. So if there are multiple years, you could have shown it like this, right? There is a, you can see it, right? But we restricted to 2019. So you can change the sheet if you want. Just a second. Stop. And then you change the filter, you get multiple years, then map also changes. Right. That way you can, there are many more options left when you do it. So two things are required for this. One is Excel and another is Tableau.
Right. So I don't think there are any questions here. Only people are, of course, amazed by the information that we have received. New concepts never heard of first time, and authentic data, we should know where to look for it and all. So yes.
Similarly, you get spelling Tableau is wrong. It is EU, I guess.
Yeah, yeah.
EAU.
LEAU.
LEAU.
Yeah.
Tableau. So that procedure, once again, I show you how to get it. Just a second. I'll share the screen. It is Tableau public. Can you see it?
Yes.
EABLEAU Tableau public.
You can download the app actually on our PC. We did.
Then you can download it, I think. And you can make this kind of graphs, which is shown. That means when you have multiple years, you can make an interactive graph like this, 62. You can see it here, right? I didn't show it. 78, 70, 87, and 92, 90, like that. That's not possible with a typical statistical software, SPSS, for example, or Stata. But you can easily do it here. That's the difference between analytics and statistics, fundamentally. So, would you like to be part of analytics revolution? This is one step.
We have some participants are asking for a separate session on Tableau. I really hope that we would be able to get some more time from you. I think we're just left with 5 minutes. So if there are no more questions, Leji ma'am, can we have the vote of thanks then? Is there any other question? So there is one question: farmers and climate change.
Okay.
Who to search or where to search that data?
Oh yeah.
He was asking it earlier also.
Yeah.
Farmers and climate change, there is ample data. I will tell you another thing. If you want data, unlimited data on anything, you go to something called GitHub, GitHub. You heard of it?
No. So could you put it in the chat?
Yeah, GitHub. Just a second. I'll put it in chat box. GitHub. You got it? GitHub.
Okay.
So GitHub will provide you ample information on anything, because people make data sets, they save it there. And if you want challenging data which can be explained to students, you can visit Kaggle.
So this is specific to what, sir?
Anything. I think it contains data on anything.
Oh,
The more GitHub, you can search again. Within it, you get data on climate or business, be it on anything. It's there.
so on particular demographics also we'll get the data on this?
Yeah. Then these data would be in CSV format. Okay. This you can read it in Tableau after cleaning it. If you don't clean it, then there will be a problem. For example, first line should be variables, but the second, if first line doesn't start with variable, something else, then variable, you have to clean it, because Tableau identifies only variables. So that kind of cleaning is needed. Then you have to use filter, and of course I couldn't show you everything. This is just a prelude.
Tip of the iceberg.
Tip of the iceberg.
Is it the same as Smart PLS?
No, it is different. It is different. Yeah.
Okay.
Okay. We'll, of course, we can have more engaging discussion later.
Yes, sir. If you permit, I would like to invite Assistant Professor Utkarsh Kapadia to give a formal vote of thanks.
Oh, sure.
Thank you, sir.
Thank you, Kalpana ma'am. It is my privilege to propose vote of thanks to Professor Bino Paul. Thank you so much, sir, for accepting our invitation and delivering such an insightful session. Sir, you not only provided in-depth knowledge about the topic, but you also demonstrated its practical implementation in real time. I am sure all the participants have gained immensely from the session. I would also like to thank our benevolent management for always supporting such initiatives taken by the college. I would like to thank Principal Dr. Sridhara Shetty for promoting and being supportive of such research-based workshops. I would like to thank Vice Principal and IQAC Coordinator Dr. Liji Santosh for organizing this workshop for the benefit of academicians in research arena. I would like to thank Vice Principal Professor Sandesha Shetty for his constant support in organizing this workshop.
Thank you.
Utkarsh, sir, you are on mute. Sorry.
Yeah. Just got a call, sir. I am grateful to the organizing and technical team for their constant assistance in the execution and implementation of the entire program. Last but not the least, I would also like to thank all the participants for being a receptive audience throughout the session. Thank you.
Thank you, Utkarsh, sir.
So I think we should meet offline and have sessions.
Fine. So let me leave. Thank you.
Thank you
for
so much
sir.
for your time. Thank you.
And of course, it was very inadequate time-wise, but of course, I thought this introduced participants to a new world with a lot of confusion.
Yes.
It's very, very preliminary at this stage, but some change is always required. I think this is what is going to shape up in years to come. Of course, this exists with a lot of confusion at this moment. Maybe it will develop in future. Yeah. Thank you. Thanks a lot.
Thank you.
The recording has stopped.
Dear participants, this next session is cancelled and we will be having our next session at 2 o'clock with Medha Tapiawala, professor from University Department. Will be engaging a session on interdisciplinary and multidisciplinary research. So please join at around 1:45 because Madam will be coming early and she will start the session at sharp. So please join at 2 o'clock. Yes, for the next session. Okay. So this coming session, because of sir's not availability, it is cancelled. And the next session will be coming up at 2 p.m. today. As sir has already told you, like he's got a meeting, immediate meeting has come up, so he had to cancel the session. So please join us at 1:45 p.m. today. Afternoon session is there today. So do join us in the afternoon. Okay. Thank you.
Just one more thing, attendance for this session as well as the post-lunch session will be taken at one time only, that is at the end of the second session. This happens every day, so all participants are requested to ask for and fill the attendance at 3 or 3:30 whenever the session ends. Thank you.
So thank you, Kalpana. Thank you, Sandesh. Thank you, everybody. John, I think we can end the meet for now because, hello, John? Yeah.
Yes, ma'am, I'll end the meeting.
Because we have next session at 2 p.m. now. So we will come back at 1:40 around. Okay.
Yes, ma'am.
Thank you, participants. See you at 1:45 p.m.